Hello coders, I welcome you all. As you can see, we have logged metrics, parameters, confusion matrix, model, code and dataset so far, right? So in this video, we are going to use randomized search CV for hyperparameter tuning to find the best parameters for our random forest classifier. As you know, hyperparameter tuning is a crucial step in optimizing machine learning models. With MLFlow, we can easily track and manage the results of hyperparameter tuning experiments. I have decided to split this video into two parts. In the first part of this video, we will log only the best parameters found by randomized search CV. In the second part of this video, we will log all the combinations of hyperparameters along with the base parameters. So let's start with our first step, this step. So in the first step, as we discussed, we are going to log only the base parameters found by randomized search CV, this one. So let's move to VS Code and let's complete this particular step. As you can see, our code, which is exactly same what we used in the last video. But I have removed the MLFlow code, which we will write again and added the randomized search CV code for hyperparameter tuning that you can see over here. So now let's visit our code one more time. So here we are importing various libraries. Here we are loading our data set. And here we are splitting our data set into two sets. One for training and one for testing that you can see over here. Train data and test data. And here is the function to fill missing values with median. And here we are filling missing values with median for training and test sets. So here we are preparing our training data, our independent variables and our dependent variable. And you can see over here, main part. Here we are defining the model and parameter distribution for randomized search CV that you can see over here. And here we are using two parameters of random forest classifier for tuning, n estimators and max depth. You can use more as well. And here we are performing randomized search CV to find the best hyperparameters from this parameter distribution that we have used over here that you can see here. And we are using 5-fold cross validation. Now next, here we are printing the best parameters found by randomized search CV. And here we are training the model with the best parameters that you can see over here. And here we are saving the train model to a file using pickle with this particular name. Now let's move on. Here we are preparing our test data that you can see over here. Independent variables of test data and dependent variable of test data. And for prediction, here we are loading the saved model that we have saved over here using pickle. And here we are making predictions on the test data. And here we are calculating performance metrics like accuracy, precision, recall and F1 score. And here we are printing results on the console for metrics. So this is our code. So now let's complete our first step, logging only the best parameters found by randomized search CV. So let's back to VS Code. And now let's use MLFlow to log the best parameters found by randomized search CV. Along with this, we are going to track metrics, datasets, model, and the code as well. So now first, let's import MLFlow. Let's save our file and let's set the tracking URI for MLFlow. So for that, we have to write MLFlow dot set underscore tracking URI. And let's set tracking URI to local host 127.0.0.1 with port number 5000. Let's save our file. Now let's move on. Let's create new experiment in MLFlow. So for that we have to write MLFlow dot set experiment and you can give any name. Let's give water underscore potability underscore HP. For hyperparameter, you can give any. Let's save our file. So we have completed 3 steps. I have imported MLFlow and here we are setting tracking URI to local host. And here we are giving name of the experiment. Now let's move on. So let's start an MLflow run to track the experiment. So for that we have to write with MLflow dot start run, and let's put all these statements inside this. So as you can see here, we are printing the best hyperparameters found by randomized search CV. So over here, let's log the best hyperparameters found by randomized search CV. So for that, we have to write MLflow dot log params, and let's copy this and let's paste over here. Let's save our file. So now let's move on. So here we are calculating and printing performance metrics that you can see over here. So here let's log the performance metrics. So for that we have to write MLflow dot log underscore metric. Let's give accuracy, comma, this one. Let me copy this and let's paste 3 times for precision, and here precision. Here recall, comma, recall. Here F1 score, and here we have used F1, this one. So now let's move on and let's log the data sets used for training and testing. This one. To do this, first we have to convert the data set into the format that MLflow accepts. So for that we have to write MLflow dot data dot from underscore pandas, and here we have to give this train underscore processed underscore data. Let's copy this and let's paste it over here, and let's assign it to one variable, train underscore df is equal to this statement. Let's do same for test data as well. Let's change it to test underscore processed underscore data, and here as well. Let's save our file. Now you can see we have successfully converted train and test data into the format that MLflow accepts. So now let's log our data sets using log underscore input train underscore df, and let's give context train MLflow dot log underscore input test underscore df and context test. Now done. So as you can see, we have logged best hyperparameters found by randomized search CV, and here we have logged metrics like accuracy, precision, recall, and F1 score. And here we have logged our data sets, train and test data sets. Now let's move on. And now let's log the source code. So for that we have to write MLflow dot log underscore artifact underscore underscore file underscore. So this way we can log source code using MLflow. Let's save our file. Now let's log the train model. So for that we have to write MLflow dot sklearn dot log underscore model, and here we have to log this one, model with the best parameters. Let's copy this and let's paste it over here, and let's give name paste model. You can give any. Now done. Let's save our file. Let's clear this and let's open MLflow UI using following command, MLflow space UI. Let's click on follow link. You can see our MLflow UI. Let's move to VS Code and let's open new cell and let's run our code. So we have created this file with this particular name that you can see over here, hyper_log.py. Let's run this Python file. Let's press enter. So as you can see over here, fitting 5 folds for each of 25 candidates, totaling 125 fits, because we are using 5-fold cross validation with 25 candidates that you can see over here, 5 for n estimators and 5 for max depth. So we have to wait. You can see base parameters found, n estimators 1000 and max depth 20, and all done that you can see over here. Value of accuracy, precision, recall and F1 score. Now let's move to our GUI, MLFlow GUI, and let's refresh. And this is our experiment. Let's click over here and you can see experiment details. And here dataset used, because we have also logged dataset using MLFlow that you can see over here. Train dataset and test dataset, because we have logged both train and test datasets that you can see over here. And best parameters, you can see max depth 20 and n estimators 1000 that we have found over here using randomized search CV that we have logged successfully using MLFlow. And you can see metrics, accuracy, F1 score, precision and recall as per these parameters of random forest classifier that we have found using randomized search CV. And you can see also we have logged model that you can see over here that you can download by clicking this particular button. Also you can see requirements.txt, and also we have logged source code as well that you can see here. So we can say that we have completed our first step, logging only the base parameters found by randomized search CV that you can see over here. Parameters and corresponding metrics as per these parameters. Now let's move on to our second part of this video, logging all the combinations of hyperparameters along with the base parameters. So you can see we have logged only the base parameters, right? But what if we want to perform more analysis? Suppose we want to check each combination of hyperparameters and their corresponding metric values as well. So for that, we need to log all the combinations. That's what we are going to do here in this particular step. So please remember, if we log all the combinations directly, it will create multiple runs over here. And if we have many runs, it may fill up this entire window, which we don't want. So what we are going to do? We will create runs based on parent and child combinations. In short, we are going to perform nested run inside run. So let me show you this practically so you can get a better idea. In short, we are going to perform a nested run, a run inside a run. Let me show you this. Let's jump to VS Code. So before we move to our second part, this one, logging all the combinations of hyperparameters along with the base parameters, I want to show you one thing. As you can see here, also I am using the same code, and you can see base parameters found, n estimators 1000, max depth 20. So if we want to print the internal process and the results of internal process of hyperparameter tuning by sklearn, we can print it like this. Let me copy this and let's paste it over here. .cv underscore results parameter. Let's execute this cell. You can see over here min fit, std fit and others. But we are interested in params that we are going to log each and every combinations. If we want to access this, let me copy and here let's paste. You can see over here. So this way we can access only params from entire results. Now also we have to use mean test score. So let's remove this. Let's execute this and we are interested in this mean underscore test score for all the combinations that we can access like this. Let me copy this and here let's paste. Let's execute this cell. You can see over here. So this logic we are going to use inside VS Code to log all the combinations of hyperparameters. Let's move to VS Code. So now let's start our second step. This one. We are going to log all the combinations of hyperparameters along with the base parameters. So this will become our parent run. Also we can give a run name. Let me give random forest tuning. And also we can give alias as parent underscore run. So this run name and alias both are optional. If we not give this run name, you can see MLFlow generates this run name automatically. But here we are giving run name explicitly, which is optional. So this is our parent run. Now let's create child run. For that, I have to write for I in range length of random underscore search dot cv underscore results, and as per number of parameters we want to rotate this particular loop. And let's create child run with MLFlow dot start run, and also let's give run names as well. So let's give app string combination I+1, and also we have to use nested is equal to true. Then only MLFlow will understand as nested run, as child run. Also let's give alias child underscore run. Now MLFlow dot log underscore params, and we have to log random underscore search dot cv results and params and I, all the combinations that we have discussed over here. Let's remove this, let's execute this cell, and this all the combinations of hyperparameters that we are logging over here. Also MLFlow dot log underscore metric mean underscore taste underscore score, and here we are going to log this mean underscore taste underscore score. Let's copy and let's paste it over here like this. So let's copy this and let's paste it over here, and here we have to use I. Let's save our file. I think all done. This is our parent run and this is our child run. So you can see inside the parent run we are logging all these things: metrics, datasets, source code, and based model, while in the child run we are logging only this combinations and corresponding metrics. Now done. Let's execute our code. Sometime we have to wait. You can see fitting 5 folds for each of 25 candidates, totaling 125 fits. So we are going to log all this combinations. So now you can see all done. You can see base parameters found, and estimators 1000 and max depth 20. And here accuracy, precision, recall, and F1 score means all done. Let's move to MLFlow UI. Let's refresh this. So here you can see our current run, and this is our parent run. And here you can see one new symbol plus. Let's click over here, and here you can see combination 1 to 25 run names that we have given like this, and name of our parent run, and this is name of our child runs that you can see over here, which is generated accordingly. You can see parent run name and child run names from combination 1 to 25. Let's click on this parent run. You can see project details, and here dataset used, because we have also logged dataset using MLFlow that you can see over here, train dataset and test dataset, because we have logged both train and test datasets that you can see over here. Our base parameters and corresponding metrics: accuracy, F1 score, precision, and recall, and model metrics. Let's move to artifacts. You can see in the parent run we are logging all these things. Right now let's move to child run. Let's click on this run combination 25. You can see value of the parameters during this particular run, corresponding mean underscore taste underscore score. And as I said, we are not logging anything during child runs. Here only we are logging parameters and corresponding taste score. So as you can see, we have generated various combinations of hyperparameters used in the random forest classifier, and we have used 2 parameters of random forest classifier, right? N estimators and max depth. Let's select all these combinations. As you can see, we have selected all 25 combinations, and let's compare them for better understanding. So for that we have to press this button, compare. You can see over here parallel coordinates plot. Let's move to scatter plot. You can see max depth on x-axis, in test score on y-axis, and here you can compare like this. Let's change it to N estimators. You can see over here N estimators on x-axis and mean test score on y-axis, and you can see like this different combinations and corresponding mean test score. So this way we can conduct a detailed analysis because we have logged all the combinations of hyperparameters like this. So this way we can log hyperparameters using MLFlow. So as per your requirements, you can log either only the base parameters or all the hyperparameter combinations like this. Now done. Hope all of you are clear with this. So we have completed our 2 steps. In the first step, we have logged only the base parameters found by randomized search CV. In the second part of this video, we have logged all the combinations of hyperparameters along with the base parameters that you can see over here. So as I said, as per your requirements, you can log either only the base parameters or all the hyperparameter combinations. Hope all of you are clear with this. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.